So anyway, like I was saying, we are starting Unit H. So that takes us away from directly working with triangles. We will still be working with triangles, so it'll just be indirect. Because Unit H is about quadrilaterals. It's kind of a short unit. We're done with it, I believe, on March 12th. We do have a few interruptions during this unit for things, hopefully not for snow days, but we do have during this unit a day off, a half day next Thursday, which will be our quiz day, and a day off next Friday. It's a compensation. I don't know why we're not using it as a makeup day, but we aren't. So whatever. You know,
I don't do anything in the summer.
Is what it is. And we do have e-pass testing that also comes on March 6th. You should have received notice about that at home, or your parents should have received a robocall plus a letter about it, or at least an email. But all students will be testing, except seniors, will be testing on March 6th. And that's that practice ACT test that we get to deal with. So just something to keep in mind that that's coming up. We've got a lot going on over these next couple of weeks. We will easily complete Unit H, like I say, though, if everything works by the 12th. Need more caffeine. All right, so, all empty. The sum of the measures of interior angles of a polygon is one, this is from a previous section we did this. But just a little reminder, we have talked before about angles in a polygon, okay? And the interior angles, we've worked a little bit on this. The sum of the interior angles for a quadrilateral is how much? 360. So what would this exterior angle be right here? Well, we'd have to figure out what the corresponding interiors are, wouldn't we? So 106, this would be an 86, or 76, that's supplementary pair. See, I can't count this morning. The 65, so that would be a 74. I told you I can't count this morning. I don't know. I think I'm swimming on a beach somewhere nice and warm. Okay. Which is strange because most people swim in the water, but I'm swimming on the beach. So. They're nice to me there. Nice young men in their clean white coats. Yes. Glad you know. All right. What would this be? 115.
That they go up to 180?
Yes.
Okay.
Because the interior exteriors have to be supplementary. 78, this would be a 102. So we could add the 115 plus the 102 plus the 74, 911. So 789, 291. So 360 minus 291 would be 69 degrees. And so this would be 180 minus 69, which is 111. There we go. By the way, so a curiosity, what if I add up those four exteriors? What are they all going to add up to? Also 360. Also 360. So kind of interesting. The exteriors for any polygon, we'll get this later in the year. It's actually in section 1. You did this as one of your theorems. The exteriors always add up to 360. It doesn't matter how many sides the polygon has. It's kind of an interesting, quirky fact. The interiors are all different, but the exteriors always add up to 360. So we may use that just a little bit. But like I said, we kind of skip section 1 and move straight into section 2 for this unit. We'll come back and pick up section 1 later when we talk about polygons and areas of polygons and stuff like that. That's unit J, I think. Because we're in H now, I is circles, J is polygons, yeah. So, quick review, angle pairs. Something from chapter 3, unit C. Name the angle pair and tell me what the relationship is for the angle pair. Angle 1 and angle 7. What do we call that angle pair? Corresponding. What's the relationship? Relationship being congruent or supplementary? Which one is it? Congruent. How about 2 and 8? Vertical. And they are congruent. How about 3 and 4? Consecutive interior. And they are supplementary. I mean, just look at it. Acute, obtuse, clearly not congruent. Supplementary. How about 5 and 6? 5 and 6 are a linear pair. Congruent or supplementary? Supplementary. Meaning they add up to 180. And last one, oh gosh, I ran out of pen colors. Maybe I could choose a different color. How about just regular blue for once? How about yellow? That's blue. Let's do regular blue. 4 and 8. Alternate interior. I am writing with my finger. It's amazing, isn't it? I got skills. What's the relationship? Congruent. Bottom line is there's nothing magic about these pens. They're just pressure spots. Anything that creates a pressure spot will do that. It's a felt tip, so it's soft on the board. Does that disappoint you? Sorry that disappoints you. I'm sorry I've shattered your illusions. Your childhood is ruined now. I've ruined her childhood. All right. Why? Because we are dealing with the parallelogram. That's two pairs of parallel lines crossing each other. Okay? Like two sets of railroad tracks crossing. Isn't that exciting? Okay? Two sets of parallel lines crossing each other. This is what a parallelogram essentially is. And if I look at any pair here, other than the diagonal pairs, if I look at 1 and 2, that's a pair of what type of angles? If I just look at 1 and 2. Consecutive interior, so they have to be Milton. I'm glad you are so confident. Well, you know, if you're going to be wrong and be proud, right? Okay. Okay. Everything's my fault. I've just come to accept that. I'm a parent of a teenager. That's the way it works. Actually, a couple teenagers. Everything's my fault. And I'm male. So, always the male's fault. Sorry, guys. It's the way it goes. All right. So 1 and 2 are something. How about 2 and 3? They have to be, they are, again, consecutive interior, so they have to be 3 and 4, consecutive interior, they have to be 4 and 1, supplementary pairs, okay? How about like 2 and 4? What do you think the relationship's going to be there? Congruent. Why? Well, we can go back to, this goes way back to like Unit B, congruent supplements theorem. Since 1 is supplementary to 2 and 3 is supplementary to 2, two angles supplementary to the same angle must be congruent to each other. Supplementary is not transitive. I mean, we know if A equals B and B equals C, then A equals C. That's transitive property. Supplementary doesn't work there. If A is supplementary to B and B is supplementary to C, then A and C are not supplementary. They are congruent. And it makes sense. I mean, obviously, obtuse to acute, acute to obtuse. Oh, these were both obtuse. They couldn't be supplementary. The relationship is congruent. Same with 1 and 4. What if we drag in a diagonal? Okay. What if I drag in a diagonal? Well, now we start getting all sorts of interesting things happening, don't we? Because whenever we start drawing in a diagonal, now we start getting our Z shapes, don't we? I've got one Z that goes that way, which means that these two angles would have to be congruent. I've got another Z, a second Z, going that way, meaning these two angles are congruent. But if these two red angles are congruent and these two green angles are congruent, and that's a shared side, what does that tell you about these two triangles? They're congruent triangles by what theorem? Angle, side, angle. Okay. Darn it, what did I say? We're studying quadrilaterals now, and so what are we right back to doing? Triangles. The triangle is the base shape in geometry. It's like trying to do algebra without the number 1 or 0. Shapes mess with your mind? Okay, I'll keep that in mind next time you want to. I do like triangles. What? I can't comment on that because if I told you, I'd have to kill you. So.
I was like, you should get a triangle of like tattoo. And then I thought about you should get a triangle of eyes tattoo. When I made connection triangles Illuminati, you must be a cheerleader.
It would be the perfect cover, wouldn't it?
Yeah. I mean, you understand.
And I'm teaching everyone about triangles, so I'm indoctrinating you all at the same time. It's all part of my evil plan. All right. So this takes us to parallelograms. Let's really talk about what a parallelogram is. A parallelogram is a quadrilateral with both pairs of opposite sides parallel. Both pairs of opposite sides are parallel. Not just one pair. One pair gives us a trapezoid. Both pairs of opposite sides are parallel in a parallelogram. Now, several rules apply to parallelograms right away. And it's pretty easy to see when we start looking at this. Besides opposite sides being parallel, okay, we use the arrows to indicate parallel. We can also very quickly, because of the congruent triangles here, opposite sides are corresponding parts of congruent triangles, so opposite sides must be congruent as well. Now, be careful, I didn't say all four sides were congruent. The opposite sides are congruent. If all four sides are congruent, we call that what? Well, not quite. Square is a special type of this special thing. All four sides are congruent. Rhombus. So it's like a fun word, rhombus. It starts with an RH. Not many start with RH. Not many, I said. Okay. RH words are rather unique. Rhyme, okay. There you go. You're shattering my illusions. Stop it. All right. So, opposite sides are parallel. Opposite sides are congruent. Opposite angles are congruent. We've already shown that one. So the opposite angles are congruent. Now, again, not all four angles are congruent. If all four angles are congruent, that means they're all right angles. It makes it a... No, not square. Rectangle. All four right angles, rectangle. And this is my good class.
I told you, shapes are bad.
Okay. Consecutive angles are supplementary. We've already talked about that in terms of consecutive interior angles. And this is the last one that's really interesting. Because those first four are fairly obvious things. But this last one's really interesting, and that is that the diagonals bisect each other. Whoa, wait a minute. That one requires a little rewind, and let's think about that for a second. The diagonals are not congruent. Not necessarily. Could they be? Yes. In certain circumstances, they can be. But generally, they are not congruent. But the diagonals bisect each other, which means that this part is congruent to that part, and that part is congruent to that part. Or this point where the diagonals intersect is the midpoint of both diagonals. That's actually going to turn out to be a very powerful thing for us. It's going to become very important when we start putting these things in a coordinate plane. Those diagonals bisecting each other, because it's going to give us the simplest way to show that something's a parallelogram, by showing those diagonals bisecting each other. But these properties of parallelograms are ones you need to know and have memorized. You need to know those properties. Most of them, like I say, are pretty simple. The diagonals bisect each other is the only one that might be a little bit like, whoa, didn't see that one coming. But it works. It's kind of nifty. So essentially what we're doing is we're going to be spending the next few days, and really not that bad of stuff over these next few days, working with these properties and applying algebra to these properties. There's a shock. We've learned properties about parallelograms. Now we're going to use it to apply algebra. We've been doing that, what, every day since the first day of geometry, right? So we'll get things like this: solve for n, or solve for x, or y, or x, and we have to understand the properties so I know how to set up the equation. How am I going to solve for n? 3n minus 5 equals 19. So we do our little bit of algebra. Show your work, please, with your algebra. I still have way too many people who put 14 here instead of 24. Okay, it's not that hard to show your work. It does save you a lot of grief later on. Some of you are actually learning that I'm not lying when I say that. That you're starting to do it more often, you're getting better grades, and it's just shocking. And it's really disappointing when an adult is right. I understand that. But you don't have to admit it out loud. You can just go ahead and do it. Quietly admit it to yourself, or still be in denial and just do it because you think you have to. However you want. Whatever makes you happy. How about x's? What am I going to do with the x's? 5x plus 20. No. That's a supplementary pair, so we have to set that up differently. And again, if we are careful and we don't jump to conclusions, they can't be equal. They're acute, obtuse, clearly not equal. So that helps me. 7x plus 40 is 180. Sorry, I got ahead of myself. Started thinking about the result of the subtraction. So 7 minus 40. 7x equals 140. So x equals 20. All right. How about on this one down here? The diagonals bisect each other. So 6y equals 24. And 12 equals 5x minus 3. And this is y equals 4. And for this, we add 3. 15 equals 5x, so x is 3. That's what a lot of your homework looks like. Problems like that. Identifying parts of and facts about quadrilaterals, parallelograms, and specific, and using it to set up and solve equations. It's not too bad. Solve for x and y. This really is as simple as it looks. It doesn't require a whole lot of thought. Y and 130 are opposite angles in that parallelogram. This is a parallelogram, I should tell you that. So y has to be 130, and x has to be 50. Seriously, that's the level of problem we're talking about here. Compared to trig and Pythagorean theorem and all that other stuff, should be pretty obvious and straightforward in a lot of cases. That's what we're working on. This is not a big, huge new day. And we're going to spend a couple days making sure you understand this, because this section and next section are essentially the same thing. The next section, we just work it backwards. and say, how can I show that it's a parallelogram? And basically, it's all these same properties. Show the opposite sides are parallel. Show that the opposite sides are congruent. Show that the diagonals bisect each other. Now, one thing I want to preview with you very quickly before we go any further, though, is remembering that we're going to wind up working in the coordinate plane. And in the coordinate plane, we prove things are congruent prove things congruent using what formula? How do we prove things are congruent? How do I prove things are congruent in the coordinate plane? Congruent means has the same measurement, right? What do we measure in the coordinate plane when we're proving segments congruent? We measure it there. Do we measure how fat the segment is? How its width? Do we measure its depth? Its length, perhaps? By using distance formula. Okay?
Is that an L? By the X?
X1 minus X2.
Okay.
All right? Now, when we looked at the item analysis of the final exam that we took at semester, one of the lowest scoring problems across the board, doesn't matter who you had for your first semester teacher, it was actually quite remarkable. When we did the item analysis, it didn't matter who your teacher was. Every class performed almost exactly within a couple percentage points the same on these problems. It was actually really quite consistent. And almost of the problems we surveyed, one of the problems is a distance formula problem. That had the lowest percent of correct answers of any problem that we looked at. Literally, it was a problem on the test where you were given 2 points and asked to find the distance between them. It was like 59% got it correct. Other problems were up around 85, 90% usually. Distance formula was one of the absolute lowest. We've been doing distance formula since the first week. We've never stopped doing it. We haven't done it for a couple weeks here, but it's not going away. You have to know it and be able to work with it. If you don't, please see me for help or come to Learning Lab and just get help. Just say, I need to work on distance formula and finding the distance between 2 points. It's very easy to make up problems. We can make up as many as you want. We can do it. Okay? If I want to prove lines are parallel or perpendicular, what measurement do I use in the coordinate plane? Slope, which is change in y over change in x, y1. Okay, let's clean that up. Okay. And if they have the same slope, they're parallel. If the slopes are negative reciprocals, they're perpendicular. The last formula that we have is the midpoint formula. So in the coordinate plane, if I want to show that things bisect each other, I need to show they have the same midpoint. So the midpoint formula is the last one. It's the only one that uses addition instead of subtraction and gives us a point. So if you don't have these three formulas memorized and know how to use them, jot them down, write them down, make sure you keep them handy. We will be using them. Not today, but we will be using them. That's just a little preview of coming attraction. I don't want anyone to be shocked when these show up again. We're going to put points in the plane and we're going to say, is it a parallelogram or isn't? Prove it. And you're going to have to take the correct measurements to do so and do the right calculations. So you need to be prepared. What are you at, 22? Well, we got 7 minutes still. Plenty of time for you to get started on your homework. How about that? I have updated the geometry homework page. Look at that. Brand new geometry homework page. Page 518, 3 through 22. There's a little bit of extra vocab there too, which basically, folks, I'll tell you what I'm going to do. Don't just copy down what was in the notes here today. These are just the properties of parallelograms. You could actually write those out in one card. Those formulas are summarized. I mean, this is basically all those theorems and definitions right here. It's the properties of parallelograms. You can do it in one note card. All 5 theorems can be done in one note, all 5 things, one note card. If you put this down with a picture, that'll be your vocab for the day. I don't care if it's on a note card. Put it in your notebook. Just show me that you've done it for tomorrow, and you get those vocab points. Yes. 3 through 22. That's it? Yep. And that's page 518. Yeah. 518, 3 through 22. All right? I'm going back. Yeah. I'm going to stop the podcast, though.